Oh, good afternoon, good evening. Let's talk today about the refactoring. So someone once said, is this really refactoring or refactoring? And why we actually refactor the code? And I want to tell you today that there is actually no fuck in refactoring. It's just a spoiler, so we will... So that's it. Thank you for your attention now. Yeah, so why we refactor? Why we refactor the code? We as the developers, usually when we join the new project, which exists for some years, we just see the code, and sometimes we just have this kind of reaction as Gerald on this GIF, because someone previously before us joined the code, that project, created the code, and then someone also forgot about refactoring. Few words about me. My name is Rafał Piekara. I'm the Ruby lover, really. I love Ruby on Rails, and I love talking about Ruby on Rails to the people. So I'm teaching people about Ruby and Rails, and I'm helping newcomers to join the community of Ruby developers. And there is no actually magic because I'm just coding. So let's go to the coding topics and how to avoid the stress in projects. We refactor the code to avoid our stress when we join the projects. But why we should refactor? Why we refactor? Why there is a state of the code when we go and we just have the idea of refactoring? So everything starts with the features. Everything starts with the features which are designed by the business. And sometimes those features are like this picture. So we just use the tape to fix some problem, but to fix it so simply, so fast, to deliver the value and to go on with the next tickets of the backlog. To deliver it very fast. But what does it mean to deliver? So business wants programmers to deliver the fresh code, to deliver the features, so that business will be happy. So to deliver for the programmer means that we do the work to make our business happy. And to deliver is also to make the developer delighted with the code, with the technology, with the project, with the libraries they develop. And sometimes the business is so angry because business wants to develop the income. Business wants to earn the money. And we as the developers need to respond on this business need and deliver the new features. So business comes to us and tells us to implement new feature. We sit down and we code. There is one feature in the backlog, there is another feature in the backlog, there is another feature in the backlog. There are features in the backlog. So we need to deliver one by one, by one, by one. We have no time, especially in the startup environment, we have no time to think, to plan, to analyze. We need to deliver and deliver. So the business wants to deliver this kind of features. Very robust, very complex. But for the developers, we usually see the algorithms. We see the database structures. We see the variables, classes, diagrams. So there is a mismatch in language. And that mismatch is projected to the code. So we write the code with this kind of mismatch of understanding of business needs, so that we finish with the code after some time, with the code which needs the refactoring, because sometimes we need this approach. We need YOLO development. When we need to test the idea, when we need to develop the MVP, we need YOLO-driven development. We need to sit down and code without any thinking, without any analysis, without any workshops, and without any meetings epidemic, which is composed of so many meetings, planning, diagramming, grooming of tickets, and so on. So sometimes there's a situation like this. And we joined this project, which should be delivered ASAP. And we are intended to deliver our new features because we are new developers in the team. So we need to show our ability to develop and to deliver more features, more values. We need to deliver it as ASAP as possible because business wants to develop still. We are hired. We joined the project. We need to deliver. We need to deliver according to the priorities. So we have the development process, which is structured with the priorities. And usually, the highest priority is the priority which is not the technology. So technology is not the highest priority while developing the features. Because business wants features. And where is actually refactoring in that? Where is actually development in that? So developing features, delivering new values one by one, maintaining projects for years makes a legacy. What is actually legacy? I like the English word of legacy because English word of legacy is a bit more positive, because in English the legacy is something which is inherited in a good way. So like the castles are the legacy. We have some history as the legacy. But when we speak as developers about the legacy, it's something shitty, something which is not sexy. So when we join the old project, like old, 1 year old is an old project, there's also legacy. And we don't like legacy. We also want to write better code. So when you think about the legacy, when you think about the projects you join, you are cursed with the legacy or blessed with the legacy. What kind of approach you can take to work with that code you inherited from other developers? And then comes the refactoring. So developers are the people who like to restructure, rework, rewrite everything, and they want to refactor. So it's sometimes I met one manager who said, developers always want to refactor. They don't want to work, they want to refactor. So what's actually the refactoring? And why business does not need refactoring? Because business needs features, yeah? Business does not understand that the refactoring is something which is making the project like unicorn. We need to refactor. We as a developer know that we need to refactor the code. We need to reorganize classes. We need to refactor with new libraries. But business doesn't know about it. And then, as we need the refactoring, we need to have correct approach. So we go to the business, we tell them, hey, business, that code is shitty, we need to refactor it. And business, we now need to deliver new things. We have the release, we have the commitment to the clients, we have the commitment to customers, we have a huge backlog of new ideas, we have commitments to investors, and so on. So, dear developer, someday you will refactor the code. So what we can do as the developers with the code, as we don't have the refactoring sprint, possibly someone of you ever had the refactoring sprint? Did you? One? Okay. So it's like, I assume it's not like the popular practice in companies to have the refactoring sprint. So what we have this tool. We have Scout rule. It's like when you are a junior developer, you are told that when you start working with code, leave it better than when you started working with it. So when you have some bad naming in the code, fix it. When you have some bad test, fix it. When you need to have some optimization in the code, fix it. So it's a Scout rule. You deliver the feature, and by the way, somewhere around, you need to fix some code. And there is a Scout rule, so you can use the Scout rule. But there is a more structured process, more structured practice, as it's refactoring actually. And here's the definition according to the Martin Fowler, that refactoring is the process. Fowler really emphasized that it's the process. It's not like a refactoring sprint. It's like perpetual work on the code base. So it's process of changing a software system in such a way that it does not alter the external behavior of the code, but it improves the styling, performance, or class organization, diagramming, and so on. So that's the theory. How is it in practice? What's the purpose of refactoring? Why Martin defines it as a process, and why Martin advises us to refactor like this? So first point to refactor the code is to improve the code readability. So sometimes the code we inherit as the legacy, in a positive way, it's our legacy. So sometimes this code is not readable because it was written like a few years ago. And now we have new practices. So we need to refactor. There's a good example in React maybe, when there are some projects with the class components and they are working, but they are not readable for new developers who learned React recently and they know functional components. So the first point is improving code readability. Second one is reducing complexity. So when we develop the features, sometimes we develop like big methods with some shortcuts, some compromises in the code. And the code is a bit complex to understand. So it's like write-only code. We write and it's perfect. We have the recursion and so on. And we write it, but it's hard to read and maintain. So we need to reduce this complexity to work effectively with that code base. Another one is optimizing the code. So when the code is slow, it's like simple thing. We need to optimize. We need to optimize queries. We need to optimize memory management. And all of those points leads to the one single point, which is ensuring maintainability of the code. We as a developer not only write new code, but we usually maintain the old code. Even when we write the code, after 1 week, we should maintain it. So it's our legacy just after 1 week. So there is another purpose, but it's cut here. Another purpose of refactoring is just when it's not my code, so I need to refactor to be mine. But it's like, I don't think it's business-driven criteria here. And when you refactor the code, the first principle which Martin Fowler emphasizes here is to not altering the functionality. So it's the principle of the refactoring. When we refactor, we should be like focused, obsessively focused on not changing the functionality of existing software. Because we need to improve the code, not the functions. So it's a common mistake, as I see like in the blog posts, in articles, there are many people who emphasizes it because it's a common mistake. It's a common mistake when you mix the developing new functionality with refactoring. To help us with that, there exist some common refactoring techniques. Those techniques are defined by Fowler in his book, but let's just go through some very simple techniques which helps us to refactor the code, like to ensure the functionality is not changed, but the code is just looking better. So the first one is just extracting method. When you have some code which is doing things, it's difficult to read because it's some cognitive load to understand what is there. So you just can refactor the code. You can just extract this calculate labor cost. Do I have the pointer here? Yeah, this calculate labor cost. So we can refactor, just extract some operation to another method. Another technique is renaming the method and variable. And I saw that it's a very common initial task for the junior developers to just improve the code naming. So the task is sometimes to extract some bad named classes and methods to better naming. So we have that, for example, this library, we have get data, it's just general name when we just need to write code fast, and then we can just improve the method name by some more meaningful name. Another technique is inline temp. So it's eliminating inline temporary variables. So like here we have discounted price and we just return it. So why don't just use the operation here? Another thing is to move method or field to another level of the object structure or to another class. So like here we have just person, we can calculate age, but why don't move this age to the date of birth? And this person here can just have the date of birth as the object parameter or as the type parameter here in the field. And here we can calculate the age directly in the date of birth. So those several techniques are just the basics, but this basic is really helpful in the scout rule. So when we have the scout rule and we don't know what to improve, we can just look for those 3 or 4 techniques here. We can always extract method. We can always improve naming. We can always remove some temporary variables. We can always move the method to another level. And those are some conceptions. And when there are some conceptions, there are also some misconceptions about refactoring. And this is actually, for me, it's like the most funny part, that there are so many misconceptions here. So first misconception of refactoring is that refactoring is just cleaning up the code. So sometimes we need to just clean up the code because it's messy, it's spaghetti, it's big ball of math. We have so many cognitive load to understand methods. We have like 8000-niki, 8,000 classes here. It's not in PHP. In PHP, they have a lot of 8000-niki. So first misconception is that refactoring is just cleaning up the code. It's not just cleaning up the code, it's to improving it. We don't remove the old code, dead code. We need to leave the code better than we inherited. Another thing, refactoring is optional. So we strongly believe sometimes that when we deliver the code, when we write the code, it's so good. So when we write the code is the best code in the world, and we don't need to refactor. Because why? Because we just have written the best code. So refactoring is actually optional for us, and I'm not sure. Also, there is another misconception that refactoring takes too much time. So there are a lot of voices like in the teams that, oh yes, we need to refactor this classes, we need to refactor this code, this module, but we need refactoring sprint. We need to have more days. Oh, if I had few days only for refactoring, I will just improve this code. But it's like misconception. We already been talking about the scout rule, and this scout rule and these small techniques I presented just before 2 minutes will just tell us that this is not true. Refactoring don't need to take so much time. And then sometimes when we just have the tickets, we have just the comments in the tickets or the opportunity there that, okay, when you add this feature, just refactor these classes because like we need to implement something new. It's a good moment to refactor it, but don't mix it. Refactoring should not, it's like philosophy maybe, but refactoring should not change the behavior, should not be mixed with the features. It's like the problem of the code review. You can't just tell what was refactored in the pull request, what is the new feature. Is the problem with testability? You need to run the regression after the refactoring, especially when it's the old code base. You don't have enough test coverage. So there's another misconception. And next misconception is that the refactoring eliminates the need for testing. I will be talking later about that when you start refactoring, you need to ensure that you have the good testability of the part of the code you refactor. So you cannot start refactoring without the tests already written, and you cannot finish the refactoring without the tests of the refactored code. So refactoring, which is actually improving the code, improving the performance, the readability, the organization of the code, does not eliminate the need for testing. We need testing every time. And the last misconception I like is that refactoring will fix any code base. It will not. I used to have some projects when we refactored it from scratch, and they weren't better after the refactoring. They were just refactored. They were just written another way, but in the same shitty way. Because when you refactor whole project, it's a fun thing. I've heard it once that sometimes when you just got some project, you need to fix something in the project. You sometimes can think that it's better to write it from scratch. We'll write it from scratch. It will be even better. It will not, because like when you are rewriting the code, you are always working in a hurry. You need to rewrite it. You don't have 1 year to rewrite whole code base. You have just short amount of time, and it's the same situation as from the beginning of the keynote, that the business wants features and they want them to be delivered very fast. And when you refactor the whole code base, it's the same situation, but it's like the light to our mind that we are just refactoring. We are making our world better as a developers. So there are also a part of those misconceptions. There are also some key principles for refactoring. First, refactoring, it's not rewriting the code. So I already mentioned that when you rewrite the code from scratch, it can also need refactoring just after that. Refactoring is improving the code, not rewriting. Rewritten code can be also bad. Testing for refactoring is critical. I mentioned it just before, and it's the good practice to start the refactoring with the test coverage. When you have the really shitty class without the test, start to write the test. And it's also the good way of learning the new code base, which is like legacy code, which is complex code, which is shitty, to start with test. Because from the test or from the failed test, you can learn how the code behaves. And then you can improve it. But to keep this behavior, you need to have the good test coverage. And the good point for the refactoring, the good practice, is just to go with baby steps, like the scout rule, but baby steps. So just to refactor one part after one part, not like you refactor the whole module, start with one method, then go to another, then go to another, and go to the class, and then go to the module, and you refactor the code base. And then refactoring needs to improve the design of the code. So after the refactoring, the code shouldn't be more complex than before, but sometimes it is, because we still refactor in hurry. And also I already mentioned about not adding the functionality together with the refactoring. So what's the best practice for that? The best practice for refactoring is to have continuous refactoring. So refactoring sprints don't work. What works is continuous refactoring with the scout rule and those small steps, those small baby steps in the code. So refactor also needs to eliminate the code smells. We, as a developers, we have our good practices, we have our experiences. We used to work with bad code bases. We used to write really bad code. We know what is code smell. I don't need to explain to you what is actually code smell. You know it. You already written it. I was writing it a lot. So what's just a shitty code, like duplicated code, duplicated methods, bad naming. Like the best code smell is bad naming. When you read the code, you don't know what is happening. There is the code smell. It's a write-only code. And the result of the refactoring should be to improve the communication through the code. So when I was starting learning programming like 10 years ago, they were practiced to comment the code. When you write the code, you submit the pull request, you need to have comments in the code. And there were blog posts, you need to comment the code, comment what's happening there. And so we finished with the code like when you have the loop, there were comments, this is a loop, which is iterating through the collection of users, each user has name, and so on. So there are just pointless code comments. But now we have this good practice to communicate through the code. The best code is the code which you are reading as a book. You read the code, you know what's happening there. And I've seen also the good comparison of the code bases with just file names. When you have the correct file structure in your like modules, packages in your applications, you can just read about the business, about the features, just reading the file names from the code base. Not only the code, the methods, the implementation, you know what's happening there. And what's also good in refactoring is analytics. So I really encourage you to analyze your code when you refactor, to analyze, to log everything you refactored. There is a good practice when you refactor the code, like for example, when you replace the old method implementation with the new method implementation, you just leave for a while that old one. You can hide it behind the feature flag, for example, or then you can add the analytics for that, and you can log the calls to the new method and check if it's behaving correctly, because you can, especially in the legacy code, your tests can sometimes omit important edge cases. So this analytics will help you. There are also some complexity metrics tools which can help you to analyze the code base in terms of, for example, coupling, cohesion between the classes, and so on. And this is also connected with the technical debt, some old deprecated libraries, warnings. We have in the Ruby world, we have just pretty good tooling for eliminating the old things, old depths. And having the class refactor, when we didn't change the behavior, for the future, we should eliminate the bugs, because the code, which is more readable, it's more sustainable, it's more reliable. So we can just develop on the code base we understand. And also we can add some usage statistics, which I mentioned. And it's also the good point when you have the Git or Git flow configured this way, then you can very easily in the Git, you can just analyze your code base in terms of the most frequently changed files. When you have some files which are changed, like you see some classes are still being modified, like 1 week by 1 week. So that means that something's going wrong, maybe. Maybe it's just the business, which is like changing requirements all the time. But maybe sometimes it's something wrong with the code, with the design, when you need to touch some classes constantly. So this is the metrics about the most changing files. And after the refactoring, we can achieve some performance improvements. And I think that the fact that application is working faster is the change in the behavior. And it's the only one change in the behavior which is accepted during the refactoring. So your system should behave better in terms of speed. So you reduce the bugs. But when you want to achieve all those goals, all those principles, you need to first define clear objectives. So sometimes we need just sit down and we want to refactor the code. We just start with like pull request, refactoring pull request, and then that pull request is never merged because we don't know what we want to achieve with this refactoring. We need to have the clear objectives here. We need to, for example, let's change our code base to domain-driven design. So we know the clear objectives, how some modules should behave, how some modules should look like after the refactoring. So what to do? First, keep changes small and incremental. It's like the summary of what I said previously. Baby steps, scout rule, I will be repeating it one by one, because those small techniques, like changing the method name, changing the variable name, extracting method, elevating method, those are small changes but will improve the code base, trust me. Second one is the ensuring adequate test coverage. So the testing without refactoring like refactoring without testing shouldn't happen. Then we can use automation, automated tools like code analytics, tech debt analytics, and we should focus on readability of the code. So we refactor to have the better code. We refactor to read the code better. And sometimes we need to prioritize refactoring. Sometimes we need to just prioritize the steps in the refactoring. So it's sometimes it's not worth to refactor the whole module, but to refactor few methods, to change the naming. So we need to have the priorities. What kind of refactoring would help us to maintain better the code base? And then after the refactoring, we need to communicate and document it, because people are working with the code. We will leave the company, and there will be another developer joins the project, and they should know what is the story. Of course, you can learn from the Git history, you can learn from the commit messages, but you need to trust other developers. They write good commit messages to just read it. And then after the refactoring, don't leave it, just review the impact, if it really helps the developers, and what not to do. So please don't mix refactoring with new functionality. I already said it. Don't refactor without tests. So we need to start refactoring with tests always. Don't over refactor. So we just start. Sometimes I had some situation in my career, and I've seen that also, that we started the refactoring of some point, and there's another part I can refactor. Oh, that class looks shitty, so I will refactor that. And like our refactoring pull request is like thousands of lines sometimes. So don't over refactor, just focus on what you know, on what you need. And also don't neglect the best practices of commit messages and working with Git. So like meaningful commit messages will help you after the refactoring, or will help other developers to understand what just happened. And then I said about the objectives, so don't rush to refactor without planning. We need to plan, we need to know why we refactor. And as well as we are refactoring, there are some pitfalls, like refactoring without clear goals will lead nowhere. And over refactoring will just make our code base less readable, will make us a lot of open pull requests never merged, because they are just too complex. They are breaking some things, they are so not reliable to merge it. And sometimes we see that rewriting something, refactor something, improve something will take just like a few hours, and actually it takes days. So we underestimate the effort. So we can just go into that hole with underestimation. And sometimes we can choose the inappropriate moment for refactoring. So we, as a part of the business we are working with, we need to share those priorities with the business, and business has different priorities because they have like commitments to the customers. So sometimes we can just go with the refactoring in a bad moment because the business is focused on something else. The business will make the pressure to deliver another thing than the improving the readability of the code. So wrapping it up. When you refactor, always remember to commit changes incrementally. So small commits will make it always better. Conduct code review during the refactorings. So refactoring without code review shouldn't happen. Like refactoring without test. Code review can help you to determine what changed in the code. Your coworkers will help you to determine if you are changing some behavior maybe you don't see, because you change, for example, like naming of the classes, or especially in like frameworks like Ruby on Rails, when you have the convention, you are changing just the naming, you are changing the behavior sometimes. And balance refactoring with development. So it's good when you deliver something, see this small baby steps in the code, when you can improve the code base with small steps, and document everything you need and you did in the code base. So what I can recommend after that if you want to have better refactoring in your project, and when you want to be better developer, just working on legacy code. So first is like the Bible of refactoring is Refactoring by Martin Fowler. Improving the design of existing code is the first book I recommend. Second one is Refactoring to Patterns, Joshua Kiriewskiego. It's also a great book, but not that great that Fowler's. Like Fowler's like the Bible. Another one is Michael Feeder's Working Effectively with Legacy Code. The Bible for the Programmers, Clean Code by Robert Martin. It's just a good source to learn the proper naming, so you don't need to refactor in the future when you read and you know how to name classes and methods. And there is another also Ruby edition of Refactoring written with Martin Fowler and Ken Beck. So it's a really good book. Also, it's the Bible for the test-driven development by Ken Beck. Also great book, but it's like in JavaScript and Node.js examples, but we can adapt them to the Ruby also. And from the like online courses, platforms, and other things like online products, there is Legacy Fighter course, really great material to help to work with old code bases, old and shitty code bases as well, and to approach the refactoring. And in the end, let me wish you something. So I wish you that you ideally before refactoring and during the refactoring and after the refactoring, it's cut it. But you have no fucks during the refactoring and before and after and so on, because there is no fuck in refactoring. Thank you very much.